You'll learn what a box plot is, and you'll learn how to read a box plot to describe the characteristics of a data set. First, let's talk about what a box plot is. A box plot is a type of chart used to display patterns of quantitative data. At its base, a box plot has a horizontal axis that defines a numeric scale. Above the axis, there is a box, which runs from the first quartile to the third quartile. Within the box, a vertical line is drawn at the second quartile. Two horizontal lines, called whiskers, extend from the front and back of the box. The front whisker goes from Q1 to the smallest non-outlier in the dataset, and the back whisker goes from Q3 to the largest non-outlier. If the dataset includes one or more outliers, they are plotted separately as points on the chart. In this box plot, two outliers precede the first whisker. By the way, box plots are also known as box and whisker plots. Let's talk about how to read a box plot. In our previous discussion, we labeled various important elements, such as outliers, whiskers, and quartiles. Normally, though, these elements are not labeled. A basic box plot looks like this. Even without labels, this box plot says a lot about the dataset it represents. Let's consider some of the questions that we can answer just by looking at the box plot. For example, what is the median of this dataset? We know that the vertical line down the middle of the box represents the second quartile of the dataset, and the second quartile is equal to the median. So in this dataset, the median is equal to 0. In any box plot, the vertical line inside the box indicates the median of the dataset. We might also ask, what is the interquartile range? Recall that the interquartile range is equal to Q3, the third quartile, minus Q1, the first quartile. In a box plot, the third quartile is represented by the right side of the box, and the first quartile is represented by the left side of the box. It looks like the third quartile is equal to about 2, and the first quartile is equal to about minus 2. So this interquartile range is equal to 2 minus minus 2, which is 4. What about the range of the dataset? On a box plot, the range of a dataset is represented by the horizontal distance between the largest value and the smallest value, including any outliers. In this example, data values range from minus 10, the smallest outlier, to 8, the largest value at the end of the right whisker. So the range would be equal to the largest value minus the smallest value, or 8 minus minus 10, which is 18. And finally, box plots provide information about the shape of the dataset. In this example, the median is in the center of the box, and the left side of the median is roughly a mirror image of the right side. So we would say that this dataset is symmetric. How about this dataset? Here the median is on the left side of the box, and most of the observations are concentrated on the low end of the scale. So we would say that this data set is skewed right. And here's another common pattern. The median is on the right side of the box, and most of the observations are concentrated on the high end of the scale. So we would say that this data set is skewed left. Here are the three common patterns: symmetric, skewed left, and skewed right. Note the difference between each pattern. Let's review what we've learned about box plots. A box plot displays patterns of quantitative data. The median of the data set is represented by the vertical line in the box. The median is the same as Q2, the second quartile. The sides of the box represent Q1 and Q3, the first and third quartiles. The two horizontal lines that extend from the front and back of the box are called whiskers. The ends of the whiskers identify the smallest and largest non-outliers. The front whisker goes from Q1 to the smallest non-outlier, and the back whisker goes from Q3 to the largest non-outlier. When the box plot does not have an outlier, the horizontal distance between the end of the left whisker and the end of the right whisker represent the range of the data set. When the data set has outliers, they are represented by dots to the right or left of the whiskers, and the range is adjusted to account for the outlier. The interquartile range is represented by the horizontal distance between the first quartile and the third quartile. And finally, box plots can reveal the shape of a data set. If the left side of the box plot is a mirror image of the right side, the data set is symmetric. If most of the observations are concentrated on the low end of the scale, the data set is skewed right. And if most of the observations are concentrated on the high end of the scale, the data set is skewed left.